Hey you guys, welcome back to RPO Restorations. With summer coming, I figured now would be a good time to talk about what I think is one of the best air conditioning systems used by General Motors during the 80s and 90s. This system was used in a wide variety of cars throughout its run, but you could always count on finding it under the hood of their body-on-frame rear-wheel drive models, especially the intermediate G bodies. I'm talking about the GM Cycling Clutch Orifice Tube system, a system that is still very much liked and missed by people today. The GM CCOT system was introduced in the mid-1970s and quickly phased into most car lines within the next few years. Its components consisted of a compressor containing an electromagnetic clutch, which I'll get into later, a standard condenser, an orifice tube, an evaporator, and an accumulator. In a CCOT system, the accumulator also contains a pressure-sensitive electronic switch. Some systems also included a muffler to reduce compressor noise. These systems were designed for R-12 refrigerant and required the use of mineral oil to keep the compressor lubricated. The newer R-134A systems will use PAG oil, so if you're doing a conversion, everything will need to be flushed or replaced, and the amount of refrigerant you'll need will be different than what's called for with the R-12. I've never converted any system I've owned. I think that you get a better bang for your buck with R-12, but that's a whole different debate. The way these systems work is this. When the AC is activated by the car, an electric signal is sent either directly from the climate control system or in later years from the ECM to the low side pressure cycling switch in the accumulator. If there is sufficient refrigerant pressure in the low side of the system and the outside air temperature is over about 50 degrees, the low side pressure switch will already be closed, and the voltage will pass through that and engage the electromagnet on the compressor, engaging the clutch. Refrigerant will be drawn through the compressor and leave as a high pressure vapor. It will then be cooled as it passes through the condenser in front of the radiator and leaves that as a high pressure liquid. The liquid now reaches the orifice tube, where its flow is restricted, causing the pressure to drop, converting it into a low pressure liquid. It then enters the evaporator, where the blower sends air over it. The air is cooled and sent into the vehicle's cabin. The refrigerant is now a mix of vapor and liquid, where it now enters the accumulator, turns back into vapor, and the cycle repeats itself. The accumulator in these systems also contains desiccant to help remove moisture. This is especially important with an R-12 system because when R-12 and water mix, they form hydrochloric acid, which can eat components and seals from the inside, causing leaks. This system is fairly simple because the pressure switch on the low side also acts as the switch to cycle the compressor on and off to regulate the temperature of the evaporator, thereby affecting the temperature of the air flowing over it. When the pressure in the accumulator reaches about 25 psi, the switch will open, causing the compressor to shut off for a few seconds until the pressure builds back up. The evaporator temperature will slightly rise and the cycle repeats. The GM CCOT air conditioning system used several different types of compressors depending on the car line. The larger HR6, Sankyo SD5, and Nippon Denso were all used, but the most common one is the General Motors R4 compressor. This compressor contained 4 pistons in a radial configuration. They're still available new from GM and relatively cheap. Always be wary when buying a rebuilt compressor. For the price, it may be worth it to go new, especially if you're still using R-12. Wouldn't want to waste it. All in all, I think the CCOT system GM used in the 80s did an excellent job. It was able to cool the cars well, and I think a lot of that had to do with the R-12. And it did it all with a lower volume of air coming out of the system's blower motor. Did you ever notice how on an older vehicle it almost feels like the blower is only pushing half the air of a newer car? What do you guys think? And are any of you still using systems with R-12? Let us know in the comments. And don't forget to tap the subscribe icon on the right side of your screen. Thanks for watching.